All right, so hello, good evening, good afternoon, good morning, and welcome. So this is our first lesson. It's going to be on chapter 0, lessons 2, 3, and 4. Okay, so we're going to talk about some real numbers. We're going to talk about adding and subtracting integers and multiplying them as well. Mainly it's about to do with negatives. Okay, so one big thing is if you don't have the copy of these notes, please make sure you go onto Canvas and get them, and then we'll be able to proceed as normal. Okay, so on the notes, usually I have a different slide set up, but we didn't make the chapter 0 book, and then the first couple lessons we don't actually have a smart notebook, so we're going to go off the notes themselves. Okay, so read through them. Yours are black and white, so what I want to make sure you do is highly annotate your notes, which is please highlight what's highlighted here on your notes as well, and then what you would do is underline the annotation that goes along with it. Okay, so what I mean by that is highlight positive numbers, and then you would underline what is important. Okay, same with here, highlight this, and then underline what the aspect of it means. So that way you guys know, and I believe highly annotated notes is also highlight and circle. So that way you guys know whatever you circle to the right of it is what is actually important. Okay, so please do that with all of this. Natural numbers are naturally occurring in the environment. 1, 2, 3, 4, 5. Okay, whole numbers. The only difference between natural and whole is natural doesn't include 0 because you can't quantify 0, but 0 is a whole number. Integers are all whole numbers, both positive and negative, so you can kind of see the difference between the two. And then rational numbers is any number that can be represented, expressed in the form of a over b, where a and b are integers and b does not equal 0. Okay, so you can actually have anything that can be expressed in the form of a fraction. Okay, so 1/2, 1/4, some weird fractions, it doesn't matter. Okay, square roots. You guys are fully familiar with that. Okay, square root of 64 is 8. All right, so how I want you guys to mentally think of this, okay, is what are they doing? Well, you're basically, if you're looking at this and your left-hand margins, when you would write this out, square root of 64 is basically saying it is 8 times 8. Okay, so 8 times 8 is 64. So you're going up. Now what you're doing is when you take the square root of something, you're actually taking half of it out. Okay, you're cutting in half because it's always something 8 times 8, whatever it is. So when you take the square root of something, you're actually eliminating one of the numbers. So that's why your answer is 8. So the square root of 64, long ways around, is 8. Okay, so those are called perfect squares. Okay, when you can do that, square root of 3 is not a perfect square, and for that case, it is an irrational number. Read through it, figure it out. Irrational and rational all together form all real numbers. Okay? All right, classify these number systems. So what I want you guys to do is tell me if these are rational or not. Okay? So you would want to go through and tell me, okay, is it a natural, whole, integer, or rational number? And tell me if you guys can do anything else from here. So this would be a rational number. This here, square root of 64, we know is 8. So technically speaking, ladies and gentlemen, if you go that is a rational number, but it is also a perfect square. Okay, so make sure you guys know this is a perfect square and a rational number. And then square root of 50. You can't solve that, okay? Because remember, perfect squares would be like 2 times 2, 4 times 4, 6 times 6, all those things. So this, ladies and gentlemen, if you put it in a calculator, will come out to be an I wrote it wrong, irrational number. All right, simple setup, okay? Just want to give you guys some clarifications, some principles as we go through these setups, okay? Classifications. Not too difficult, but make sure we run through these. Now, once you guys can do that, what I want to make sure is you graph these on a number line in order from least to greatest. Okay, so you guys can look at these. If you're struggling with some of these, like I don't know what the square root of 15 is off the top of my head, I really don't, put it in a calculator and see what the answers are. Okay, so I'm going to go grab a calculator, but you work on these here. Now, what you would want to do is just give me a couple numbers. So there's this 1, 2, 3, 4. It doesn't matter how you do it, ladies and gentlemen. Just space them out. Put them from least to greatest. Okay, so make sure you guys know it starts least to greatest. You practice. All right, so on these guys, make sure as you're going through, you know the setups. you know the solutions to it, and you just simply fill it out. So I know square root of 9 is 3. Square root of 15 is the one I don't know. So let me go on my calculator here. Square root of 15 is 3.87. So I'm going to do 3.87 right here. I know this is 3.75. So now I know I've got my answer. So this is going to be square root of 9 because that's 3. It's going to be 3.3 repeating. Then it's going to be 3.75. And then lastly, it's going to be the square root of 15. So there are my dots. Let me erase this one right here because it kind of got a little wonky. Like I said, doesn't matter where it's at, just put a dot anywhere on the line. The correct thing is to make sure these are in order from left to right. Next on the sequence board, we have 4.7 square root of 20. I have no idea what that is. Square root of 20 is 4.47. Okay, this would be 4, and then you have 4 to the third, which would be 4.3 repeating. So now I know my setup. Okay, so my first point here be 12 over 3. Sorry, that's supposed to be a 3. There's 1 point. My next one would be 4 and 1/3. So 4 and 1/3. We go somewhere right here. Like I said, this part doesn't matter as much. Square root of 20 would be next, and the last would be 4.7. Please make sure when we have our quiz that you guys can do this. Okay, use a calculator, get the answers as you go from there. Simplifying roots. Okay, so what you're doing is you're taking the square root of the pieces inside of it. So what would be the square root of 9? So it's whatever number can be divided by basically 1/2. Okay, so if I put 9, what it would be, it'd be multiplied. It's not multiplied by half, but you're basically taking whatever two numbers multiplied together, make that number. So you guys understand the top number here, square root of 9 would be 3. Square root of 64 would be 8. So your answer is 3/8, okay? Because remember, it'd be 8 times 8 is 64. 3 times 3 is 9. So you're kind of working backwards on this, all right? This would be negative right away because you don't change that. Square root of 16, what two numbers that are same multiply together? Be 4. And then 121, 10 times 10 is 100. 11 times 11 is 121, okay? And then last but certainly not least, the square root of 8, okay? So here's the problem with this simplification here. I don't know if you guys have learned this yet. Can you take the square root of 8? The answer is no, you cannot. So I would want you to put it into a calculator. Square root of 8. And then you would give me the rational number on this one, irrational, which would be 2.82843. Okay, that's what I'm looking for on that. All right, so that's a little bit of real numbers, simplifying some roots. We'll get more in depth on this later on in the year, and we'll make sure we go a little bit crazier with it. All right, absolute value signs. I'm not sure about this aspect of what they want you to know. Here's what I want to make sure you guys understand, okay? Add integers using absolute value. I'm not worried about that absolute value part, but this is what I want to make sure you guys understand. Coming into algebra, you have to be able to add and subtract negatives to number, okay? I want you guys to understand the mindset has to go away about adding and subtracting now. And this is what I mean. Negative 11 plus negative 7. What are you doing to solve this? Are you adding these numbers together or are you subtracting them? Okay, I need you to think of this as money. Okay, so what you'd want to do is you're not adding or subtracting, but you're putting these numbers together. So I have a negative 11 and a negative 7. If I put that together, what do I get? You need to think of it in money like this. If I go spend $11, okay, and then I go spend $7 more, because that's what you're doing. It's a negative number. How much money have I spent in total? Well, the answer would be what? Negative 18. Okay, so you need to think in terms of money sometimes when it comes to a negative value. Okay, here's this one here. All right, so this would be saying the same thing. Okay, you have negative 5 and then you add 12 in it. So say for example you spent $5, but then you got paid 12 bucks. How much money would you actually have when it's all said and done? This would in fact be what? It would be 7. Okay, so it'd be the same aspect would be if I had 12 bucks and then I spent 5 of it, how much do I have left? you have 7, okay? So an analogy needs to go through your guys' head as you're going through this, okay? So this would be kind of the same thing, all right? Each positive integer is paired with a negative. It's additive inverse, so subtract the positives. So what I need to make sure you guys do is understand what the subtraction means now. Is that it's positive 18, okay, so this is positive 18, and basically you're going to add or subtract a negative 23. This can also be written as 18 plus negative 23, just like that. Okay, this is the same way. It'd be 35 plus negative 82. All right, this negative in front of it means that this now is a negative number. Okay, so in algebra, you have to think of positive and negative numbers now. Okay, so as we go through, say this is the same situation. Okay, if you had 18, but you spent $23, okay, how much would you owe now at this point? Because you spent more than what you owe, so in this case, you'd end up with negative 5. All right, this one here, same thing. All right, you would have negative 82. So you could say to yourself, all right, it doesn't matter which way you go. Say you have $35 and then you spent 82. How much money would you have left in your bank account? Well, it'd be negative. We know that. But what is the actual number? Okay, so you can think of it in terms of you owe somebody $82 and you paid them 35. How much do you now owe them? So on my calculator, I'll set this up and just put this in, and the answer, of course, is going to end up being negative 47. Okay. There's an aspect of this where I want to make sure you guys understand additive inverses and make sure you guys get how things are changing now as we go through. Okay. Same with these symbols here. Okay. Negative and a negative is positive when you're multiplying and dividing. Okay. So on this one here, 4 times a negative 5 is going to be a negative number, and it's actually going to be negative 20. All right, negative and a negative is going to be a what? A positive number. Now, if you struggle with this, what you'd want to do is put it in your calculator, okay? What I don't know is, I don't know what 57 divided by 3 is. It's 19, okay? Any number divided by itself that's negative and a negative is going to be positive, so this turns out to be 19. So what I want you to do is work on C and D and tell me what the answers are. All right, negative times a negative turns it into a positive, and that would be 150. Now I put a plus there, you don't have to put that there. It's just something I'm doing. Negative 108 divided by 9. Comes out to be negative 12. All right, so there are the aspects that you guys go through the setup. Last but certainly not least with this lesson is adding and subtracting rational numbers. Order these first, okay? So if you order these, go ahead and tell me if you need to convert these to fractions, okay? This technically would be 1 over, you could reduce that to, I think, 2, it would be, so what you would want to do is you'd have to put this in and make sure you guys get the actual equation and figure it out. So like 4 divided by, I do know that 4.3 is 4 1/3, I believe. So let me see. So what you would want to do is figure out which way to go. So when you order these rational numbers, you need to make them either all fractions, okay, or make them all whole numbers. So 4 times, so I'm going to put that in the calculator, 4 times 1/8, or I'll just actually do 1 divided by 8. 1/8 is going to be 4.125, okay, that's this one. And then 2 divided by 9 would be 4.222. And then this one's 4.3. And then your last one, 1 divided by 10 is going to be 0.1. So this would be 4.1. So the question is order these in rational form. What you would want to do is make sure you guys annotate and go from there. Where this number set up, sorry, I was trying to think of how I was going to do this. This number here actually goes in front, and then that's how you would order it. So it'd be 4.1, then this one, then that one, then that one. That's pretty much simple. Now you're going to talk about adding these up, okay? Adding and subtracting like fractions. You guys should remember this from 8th grade elementary school. As long as the denominator is the same, you can add the numerator together. So it'd be 3 plus 1, which is 4/5. This one here, you're subtracting, so we know it's over 10. but it's 3 minus 9. So you have $3, you're spending 9, you're putting those two together, you've got -6. Okay, and then this one here you have to make as a mixed number or improper fraction. So this would be 7 times 2, which is 14. 14, 15, 16, 17 over 7 minus, that's 28 plus 1, 29 over 7, which ends up being 12 over 7. It's because 29 minus 17, and that's a negative number because it's 17 minus 29. So your answer ends up being -12 over 7, okay? If you have any questions about something like that, please come see me in class. And then this is going to be the last little piece I believe we're doing. Let me verify. Yep. Okay, so now you add and subtract unlike fractions. So first thing you got to do is make sure that you guys learned about this. Remember, the denominator is the same. So I'm going to go with the 6. So if I got this to 6, it's going to be plus 6. What number did I multiply this by to get to 6? It'd be 3. So 2 times 3 is 6. So you got to take the 3 to the top. This would be 2, so this would be 4, and then it'd be 7 over 6 is your answer. Same thing here, okay? Go with the easiest one that you guys can think of. In this case, it would be 36. So I'll just go 36 minus 36, and then this would be multiplying by 4, so that's 20. This would be multiplying by 9, so that's 9. And your setup would be 9 minus 20, which is 11 over 36. And then the last one here, try to do it on your own real quick. All right, when you set that up, ladies and gentlemen, please make sure you have it to 28 over 28, and it'd be minus, okay? And then as you go through here, what number did you multiply? 4, so 4 times 3 is 12. This would have been 7. 7 times 3 is 21. So 12 minus 21 is going to be over 28, but it'd be what? 8, 9, and it's a negative, okay? So please make sure you guys understand that. The same thing happens with the decimals, okay? As you guys go through, you would add and subtract the decimals together. I'm not going to give you the answers for these. You guys should be able to figure these out, okay? But what you're doing is, remember, if you have a negative and another negative and you're putting it together, I look at this as like money. This is $13.12. This is like $8.60. So if you're spending all that money, you're not magically gaining money, you're going farther in debt, okay? So please make sure you guys fill the rest of these notes out. In class, we'll talk about more aspects of this, but please make sure you understand how the negative works now, okay? It's adding and subtracting is kind of out the door a little bit, okay? You're still adding and subtracting, but what you're doing is you're putting two numbers together, a positive and a negative, 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 positive, positive. You're putting those two numbers together. Basically, imagine it as one pile of numbers here and one pile of something in together. You're pushing it all in like you're playing poker in a poker match and you're pushing your chips in. You're putting like things together and you're realizing coming up with some brand new number. As you move forward, if you struggle with this concept, please make sure you see me because it's very important. Have a great day, and I'll see you guys next time.